Hello coders, welcome to our channel Level Up with Coding. Today I will discuss today's weekly Leetcode contest named Harshad Number. So basically the question says an integer divisible by the sum of its digit is said to be Harshad number. You are given an integer x. Return the sum of digits of x if x is a Harshad number, otherwise return -1. What is the Harshad number? The Harshad numbers, the number sum of digits is divisible by the number. Okay, so there you can check x is equals to 18 na? So 18 1 plus 8 equals to 9, so 9 is also divisible by 18. Okay, so the explanation they are saying that the sum of digits x is 9 and 18 is divisible by 9, so 18 is Harshad number and the answer is 9. Now we are describing it in pen and paper. Okay, so Harshad number we are discussing now. Okay, Harshad number is basically what? In this question they are saying Harshad number is basically the number that's variable sum is like 2 plus 1 is equal to 3 and it's also divisible by it, then it's basically Harshad number. Like example 1, 21, so 2 plus 1 equals to 3 and it's divisible by 21, so this is a Harshad number. And example 2, x equals to 18, so 1 plus 8 is equals to 9 and 9 is also divisible by 18, so it's also a Harshad number. But 23, 3 plus 2 is what? 3 plus 2 is 5 and 5 is not divisible by 3, so it's not a Harshad number. So I will return there -1, because they are saying whenever it's not a Harshad number, then you will return -1. Okay, so I will return -1. Now how we check this is a Harshad number or not? So we have an easy approach how we checking. Okay, so first of all find the sum of digits. First find the sum of digit. How we find it? First of all create a variable variable sum to store the sum of digits. Okay, sum of digits. Then use a loop like while loop. Okay, iterate through the x or variable or the nums that they are given us. Okay, then in this loop, in this loop each iteration extract the last digit by what? We know na, to extract a last digit we will use a modulo operator is very easy. Then what? Then add the extract digit to some variable, okay, to some variable, and then divide x and then divide the original number, that is x, by 10. Okay, to remove the last digit, when it's done, you easily check with if and else condition that the original number, that is x or original number, what you say is divisible by sum and it's 0 equals to, then it's a Harshad number. Or not, then return -1, that we saying. Okay, very easy. So how we do it right now? This approach is very easy. Okay, so how we do it right now? Look like, so first of all we saying ki first of all we are initialize a sum, so we are initialize a sum that is 0. Okay, and our original number is what? 21. Okay, because we are using the first example. So yeah, first of all what we are doing, calculate the sum of digit of the number. ठीक है. So how we first of all we are using a loop. So loop original number is greater than 0. Okay, because you are knowing na, when it's less than 0, then it's written -1, and -1 in the while loop, it's infinite numbers are coming up. So that's all. So in this while loop, in each iteration extract the last digit, okay, by using what? Modulo operator. Okay, so int we are using num, and what we do, extract original number to extract the last digit by 10. So what it's written, so num is basically original number is 21 and modulo by 10, and it's written as, and then what we will do, then add the digit of to the sum variable. Okay, so we initialize the sum is equals to 0. Sum is basically 0 plus what? Add them, na? Add it. So add it, and it will given us 1. And then what we will do, divide f by 10 to remove the last digit. Okay, so origin is basically divide करना होगा. So 21 divide 10, and it's written 2. Okay, so first iteration is complete. Okay, so after first iteration, what's the original number? Original number is 2, and what's the sum? Total sum is 1. Okay, in next iteration we do a next iteration, because original number is now 2, and while condition is what? Original number is greater than 0, so 2 is greater than 0, no? So do a second iteration. So while same, and in int num is equals to what? Number is equals to what? So now the number is 2, original number is 2, so 2 modulo is what? 2 modulo 10. So when we do 2 modulo 10, then what will return? 2 modulo 10 is basically 2. So now so sum is what? Sum is basically sum previously sum was 1, and now we will add it. We are discussing about it now, so we will add it. Then sum is basically 3, and now the original number is what? Original number is what? Original number is 2 modulo, so 2 divided by 10 will when we do 2 divided by 10, it will return 0. And now the sum is what? You are checking sum is now is 3, and the original number is 10, and it's now 10, and it's easily checking the while condition, because it's 0, and 0 is what? Greater than or equals to 0, na? Or less than or equals to 0, na? So done the loop, and sum is the answer. It's coming, na? So then when it's come and the loop is end, then after the loop you are easily check what? 21 the original number, and by 3 is equals to 0, then return the sum is what? This is, and else return -1. Okay, very easy approach and very easy question. So now we are code it. Now we are coming to our code editor, and I am code it previously. You can check it. So basically we initialize a sum that is equals to 0, and the origin that is equals to x is basically the number, and now we are calculating. Okay, so that's why we starting a loop that x is greater than 0. We are calculating the sum of digits. Okay, so in the loop we initialize a r that is basically x modulo of 10 to extract the last digit by modulo operation. Okay, then we are sum with the r that I initialized. Okay, so basically add the extract digits. It's add the extract digits. Okay, now in the next step we are divide x by 10 to remove the last digit. Okay, so that's why we are doing it. In the loop, in the end of the loop, we are just checking if the origin is divisible by sum, then we will return the sum, else we will return -1. Very easy code. Okay, Now we are discussing about the time complexity and space complexity. So first of all, space complexity is of 1 because the code is used a constant amount of extra space, and the time complexity is basically of log 10 base x. Okay, because the number of iteration in the loop is proportional to the number of digit in x and in base 10. Okay, so it's submitted and 100% faster. Okay.